It does. Now there are waivers. I don't think we've used yours. You can talk with Ms. Du Bois about that because every high school student receives a waiver to take it once. So you can take it one time for free. If you qualify, for some students do qualify to be able to take it additional times, just based off of just the different circumstances, you could qualify for a second free one. Or free in quotes, I think the state technically pays for it. But you can check into that if you do want to take it again. And the possibility, I don't know how the waivers would work with doing the individual sections, but you could see and do it that way, especially if you want to improve one of the scores specifically. Yeah. Now, before we get started with 5.41, are there any questions on any of the assignments thus far? Now, what we're doing today is not as bad as it might seem. What we can think of this as is the reverse of the square root method. Because with the square root method, we got x squared, or the set of parentheses squared, by itself and then took the square root of both sides. Here, squaring each side of the equation, squaring method, if two expressions are equal, then their squares are also going to be equal. So if a is equal to b, then a squared is equal to b squared. We can square both sides and still have it be equal. And what we're talking about is this here, these solving radical equations. And the first main step in solving any of these here is to get the radical by itself. So the first main step, let's say, kind of first question, is there one radical? If so, get it by itself. So we have one radical here. We want to get it by itself. Now we're not so much focused on what's inside the radical, just the radical itself. So if I want to get that radical by itself, what can we do? Or what's the only thing with the radical right now? B plus 5, yes? So if I want to get it by itself, we can. Subtract 5 from both sides. And if we subtract 5 from both sides, we get the square root of x is equal to 8. Is the radical by itself? Yes. And again, when we define it to be by itself, it doesn't matter what's inside. We can have more than one thing inside the radical. It's just having the radical by itself. Now, once we get the radical by itself, we're going to put both sides to the nth power. Put both sides to the nth power. Now, when I say nth power, it's really whatever index we have. So here we have a square root. Well, what exponent can I put with the square root of x to make the square root disappear or go away? We'd put the what power? The 2, the second power. Because the square root of x squared, well, the square root and square will simplify each other out, leaving us with just x. And what we do to one side, we have to do to the other. 8 squared is 64. X is by itself, and we're done. Now, if we wanted to put, really, there is a third step, and that is solve, or I think, well, we can really ask ourselves, are there any radicals? Any radicals? And this is going to really come if so, repeat steps 1 and 2. And then we could say solve at the end. And we'll get into those, especially if there are any radicals, repeat steps 1 and 2. But that'll come more tomorrow. And really, not tomorrow, but next week. We're not going to really cover that till next week. Bless you. Step 3 is really, today specifically, will not come into play. We will not have any that where we're going to have a radical still left over at this step, or trying to get it by itself. So we can look at this one here. 3 minus the square root of x equals 0. Well, first main step, is there one radical? Well, yes. There is one radical. So, get it by itself. What's the first thing we can do to get the radical by itself? We can subtract 3. And if we subtract 3 from both sides, we have negative square root of x is equal to negative 3. What can we do next? Well, is the radical by itself? I mean, there's nothing added or subtracted to it. What do we have in front of it? Negative. So we need to either divide both sides by negative 1 or multiply by negative 1. We can do either. Because negative square root of x divided by negative 1 is just square root of x. Negative 3 divided by negative 1 is 3. So, okay, we got the radical by itself, yes? Put both sides to the nth power. Well, our nth power in this case is 2, because we're dealing with square roots, so it's just going to be 2. So here, the square root and square will cancel, leaving us with just x is equal to 3 squared is 9. And that's it. Now, we don't add the plus or minus because whenever we square both sides, we just have one number. Because when we talk about the square root, when we use the square root property, we said x squared is equal to 9. Squared both sides, we said x is equal to plus or minus 3. And the reason for this is because 3 squared, 3 times 3, positive 3 times positive 3 is 9. Negative 3 squared, which is the same as saying negative 3 times negative 3 is still positive 9, yes? in our case here, I'm going to take it from this spot here. We're saying the square root of x is 3, yes? Well, if we do 9, square root of 9, well, that's just saying the square root of 3 squared, which is indeed 3, yes? Well, the square root of negative 9, well, we know the square root of 9 is what? 3. But the negative is going to be I. We can't have that. We don't have the plus or minus situation. Does that make sense? So whenever we're square rooting both sides, we don't add the plus or minus. When we take the square root, when we square both sides, we don't take the plus or minus. When we square root both sides or take the even root of both sides is when we add it. Squaring does not. Does that make sense? Mm-hmm. Okay. Do we have one radical? Yes. Get it by itself. Is it by itself? So we do what? Put both sides to the second power. Those will cancel, telling us x is equal to 36. Now it says on this one here, and it probably says on all of them, check your answer. All that means is plug our answer back in. Is the square root of 36 equal to 6? That's the question. Well, square root of 36 is 6. 6 does equal 6. It works. Questions on any of this here? And again, especially on the test, where if it says check your solutions, all you're doing is plugging them back in. See, do they give us a true statement? And the reason we have to do that is because whatever goes inside this radical cannot be negative. We cannot take the square root of a negative number or an even root of a negative number. Odd roots, fine. Even roots, we cannot. Any other questions on these here? Do we feel comfortable with these here? Yes? I want to skip over to example 2 because I feel like we've gotten the hang of this, yes? Now looking at this here, well, is there one radical? Yes, we still just have one radical. So get it by itself. What's the first thing we can do in getting the radical by itself? We can subtract 3 from both sides, which tells us 4 times square root of x plus 2 is equal to 16. Is the radical by itself? No, because what's with it? 4. So we can do what to both sides? Divide both sides by 4. Because our 4 and our square root would be multiplied. So to undo multiplication, we would divide, leaving us with the square root of x plus 2 is equal to 4. Now is the radical by itself? Yes. Now we do have that x plus 2, but is the x plus 2 inside or outside the radical? It's all inside. All of that's contained inside the radical. So even if we had it squared or other terms inside the radical, this here, the radical is by itself. Because everything inside the radical here, x plus 2 is being trapped by that radical. So that takes us through steps 1 and to step 2. Put both sides to the nth power. So we put both sides to the second power. We'd square both sides. Because the square root of x plus 2 squared, well, the square root and square would cancel, leaving us with x plus 2 is equal to 16, yes? And then we'd circle this and say this is our answer, yes? No, I said that on purpose. Because what? Is x by itself? No. Step 3, we hadn't talked about, there's no radicals left. So step 4, our last step, is to solve. Because it's not always going to work out that we just have the square root of x. So at this point here, we can subtract 2 from both sides, telling us x is 14. So any questions on how we found the value of x? Now at this point here, we can check this. 4 square root of 14 plus 2 plus 3 is equal to 19. So if this is the value of x that works, and it should be, this should give us a true statement. And again, on the test, I would set this up to check it and then plug all this in. 4 second square root of 14 plus 2 plus 3 is, surprise, surprise, 19. So we're saying 19 is equal to 19. It works, so that's our solution. Questions on this here? We'll look at one more like this and then move on, because I feel like y'all are getting the hang of this pretty quickly, yes? So again, first thing we need to do, well, is there one radical? Yes. Get it by itself. So we can add 1 to both sides. Telling us 3 square root of x plus 5 is equal to 12. Then we would divide both sides by 3, telling us the square root of x plus 5 is equal to 4. So it takes us through step 1. We get the radical by itself, put both sides to the nth power, and again, our nth power in this case is 2, because the square root and square would cancel. Telling us x plus 5 is 16. And last but not least, we would subtract 5 from both sides, telling us x is 11. And with all the problems that we've had so far, this is our only solution. This one works. Having x as 11 will not give us a negative inside this even root, and it does come out to be a true statement. Because we can't have negatives inside of a radical, and the number that comes out of a radical cannot be negative. Because when we talk about square roots, we're talking about a number times itself. I can't multiply a number by itself and magically get a negative number. Any questions on these here? Do you feel good about these? So, I don't think we're good with most of these here, yes? Up to example 3, yes? Now this one here seems like our steps kind of fell apart. Because our first step was, is there one radical? If so, get it by itself, yes? That was our first main step. And let me go back to our steps. There we go. So our steps. If there's one radical, is there one radical? If so, get it by itself. I left B there, and I think y'all did the same, yes? If more than 1, even them out. If more than 1, even them out. And what I mean by that, even them out, if there's 2 radicals, I want 1 on either side. If there's 3, I want 1 on one side, 2 on the other. Doesn't matter how I do it, which side has 2, which side has 1, but I want 1 and 2. If we have 4, we won't get to 4, or really 3. We'd have 2 and 2. we want to try to keep them as even as possible on either side. I don't want to have two. In this case here, I don't want both radicals on the same side. It's going to make it a little harder to work with. And especially if I just have two radicals, nothing else, these here are actually quite nice. And if I have more than one, even them out. We don't have to worry about getting it by itself. We need to mainly focus on even amount. So here we have two, one on either side. Yes? They've been evened out. We go to step 2. Put both sides to the nth power. What power are we going to put both sides to? 2. Let's see what happens. Well, on the left-hand side, the square root and square cancel, leaving me with 2x minus 1. The right side, square and square cancel out, leaving me with x plus 4. Step 3, are there any radicals? No. All the radicals are gone, yes? So we just need to solve. Well, the first thing we can do is subtract 2x from both sides, yes. I mean, there's many different things we could have done. We could have added 1 to both sides. We could subtract 4 from both sides. I could have subtracted x from both sides. It's just dealer's choice. Because here, 2x minus 2x is 0, so we have negative 1. X minus 2x is negative x. Now at this point here, we'll need to subtract 4 from both sides, telling us negative x is equal to negative 5. So what's the value of x? Well, if negative x is equal to negative 5, x should equal 5. Or all we can say is that I multiply both sides by negative 1. Negative 1 times negative x is positive x. Negative 5 times negative 1 is 5. We could have divided both sides by negative 1 and gotten to the exact same answer. And if we wanted to check this, we could just plug this back in. Square root of 2 times 5 minus 1 equal to 5 plus 4. And we can plug this into a calculator. Second square root 2 times 5 minus 1 is 3. Root 5 plus 4 is 3. So 3 is indeed equal to 3. That's it. Questions on these here? Questions on any of this so far? I have a feeling when y'all saw these here, especially the last one, this looked like it got harder, not easier. It actually kind of got easier, not harder, especially when we have square roots on both sides. So, this is what we're starting with. Is there more than one radical? Yes. If more than one, even them out. Are they evened out? Yeah, we got one on either side. So we can move to the second step. Put both sides to the nth power. And in this case, our nth power is 2. And on both sides, the square root and square will cancel because there's only one term. We don't have anything else there. Which is going to leave us with 4x minus 3 is equal to x plus 9. Now, it will make some complications, especially if one of the sides had a number or something else added to it. If we had the square root of x plus 9 plus 1 on the outside, it would make it a little bit different. But now at this point here, we just need to solve. So the first thing we can do is
minus x from both sides, which will tell us that 3x minus 3 is equal to 9. Next thing we can do is add 3 to both sides, telling us 3x is equal to 12. Divide both sides by 3, telling us x is equal to 4.
At this point here, we can plug it back in and see, yes, that is the correct answer. Any questions on this here? Any questions over anything we've done so far? We're going to do one more of these and then move on to the next type. Okay. Looking at this one here, is there more than one radical? Yes. So, if more than one, even them out. And we have them evened out.
No, we've got 2 on one side and nothing on the other, yes? Well, nothing says I can't just add it to both sides. And I want to try to keep the radicals positive if at all possible. Because negative square root of 4x minus 7 plus square root of 4x minus 7, these become 0, leaving me with the square root of 3x plus 1 is equal to the square root of 4x minus 7. I just needed to get 1 on either side. Now that they are evened out, we're going to put both sides to the nth power. And again, our power that we're using this time is 2, which will cause the square root and square on both sides to cancel. And again, the reason we can do this is because there's only one radical. On either side, there's nothing else. And what that will leave us with is 3x plus 1 is equal to 4x minus 7. Now at this point here, we need to get x by itself. So what can we do first? Minus 3x. Most likely, I think that's a good step. Because if we'd have subtracted 4x, we would have gotten negative x instead of positive x. Here, these become 0, giving us 1, is equal to 4x minus 3x is x minus 7. Subtracting 4x from both sides would not be incorrect. You'd still get the same correct answer. But it might add a step or two to it. But that makes us have to add 7 next. Because negative 7 plus 7 is 0, giving us x by itself. And 1 plus 7 is 8. So here the final answer is x is equal to 8. Questions on any of this here? Are we ready for the next type? This one's different, isn't it? Now, definitely when we wrote the steps out, it seemed very odd the way that I phrased them, or specifically phrased them in this fashion, and especially step number 2. Now, step 1, is there more than one radical? No, we've only got one. It's not a square root this time, but it is a cubed root, yes? Okay, let's ignore it for now. But is it by itself?
Yes, there's nothing added to it. There's nothing subtracted from it, multiplied. It is by itself. So we go to step 2. Put both sides to the second power. Is that what we have? Well, no. We have what? Put both sides to the nth power. So, okay. But this time we're not putting both sides to the second power. We're going to put both sides to what? The third power. That is why when I wrote the steps, or had y'all write the steps for how we do this down, I put nth power. Because as nth power, any radical. Because whatever the radical is the power we put it to. And if we just said square, that only works with radical square roots. Here, cubes, these would indeed cancel. Telling us 5x minus 2 is equal to, well, 12 to the third is 1,728. We would expect it to be a decently big number. And if y'all didn't know what 12 cubed is off the top of your head, you're perfectly fine. Now again, well, step 3 is again still waiting to be used. It won't come into effect till next week. But our next step is to solve. So we just need to solve this for x. We can add 2 to both sides, which tells us 5x is equal to 1,730. Last but not least, we would divide by 5. Pull the 1,730 divide by 5 nicely. Yes, because we would have 346. And that'd be our final answer. And again, we could plug it back in to check it. Because I could say the cubed root of 5 times 346 minus 2 equals 12. It was it minus 2 or plus 2? Does equal 12. That's it. Now do be careful, especially with those, because if we had a number in front, it was like 4 times the cubed root. If you do 4 and then the cubed root, the yellow calculator will have a very good tendency to want to pull that 4 with it. So just be careful with that when plugging it in. Questions on these cubed roots? We felt like it's really, from our experience in math class, seeing this here, it felt like there should have been something new. There should have been some new way to solve this, but not really. There really isn't. Because no matter what we have, any of these here, it's not changing. The process didn't change. It's just that our power we put both sides to did. Does that make sense? And that's it. That's really it for today. Now we will come across some of the other types where we will have some that our solutions will not always work. There will be some extraneous solutions, or some where step number 3, are there still radicals, comes into play. But that one most likely will not take place till almost Tuesday, maybe part of Monday, but definitely Tuesday.